My name is MAZLAN MUSTAPHA and my meeting number is AA201204. Today I will begin the presentation for my group with chapter 1, that is Introduction. First we will see about background research. The Curie brothers were the first to discover about piezoelectric. They discovered that applying force on crystals may generate electricity. When force is applied to material like quartz, toppers and tourmaline, electricity is generated. Piezoelectric begin to grow into a technology that will be used in sonar, hydrophones, microphones, accelerometers, and ultrasonic transducers at the point. Kawai's 1969 discovery of a significant piezoelectric effect in the polymelylene fluoride polymer increased the number of applications requiring mechanical flexibility. They are currently piezoelectric materials based on barium titanate. Today's piezoelectric uses include smart materials for vibration management, aerospace, and astronautical application of flexible surface and structures, sensor for robotic applications, and new application for vibration reduction in sports equipment such as tennis racket and snowboards. Piezoelectric sensor have industry uses. Piezoelectric sensors from the industry sector are used in a variety of applications. Sensor for engine knock, sonar equipment, and ultrasonic cleaning are just a few examples of our daily applications. Next, we will see about problem statement. Many sectors are depending on electrical power to continue their daily lives. Electricity problem in rural areas are causing various problems. The main problem here is the failure to generate electricity to light up roads in rural areas. This is because load shedding is being done. Load shedding is the interruption of electricity supply when there is not enough electricity to meet the demand. It makes motorists extremely difficult to spot dangers such as pedestrians. If this situation is taken for granted, it will definitely lead to loss of lives. Furthermore, without renewable source of energy for electricity, there are transboundary implications that will affect many lives in the long run after the non-renewable source of energy have been depleted completely. The step taken to initiate an alternative source of generating electricity to invent a prototype to generate electricity. The idea is to invent a pit-stop power generator which uses piezoelectric plates to generate electricity. This prototype will be placed at the traffic lights where cars need to stop. The weight of the car will be used to pressure the piezo plates to produce electricity. The current generator will be first stored in a battery, then forwarded to the lights by night when roads are hard to see. They depend on outer sources to generate electricity, and load shedding can be reduced or avoided in the future by implementing the idea. We will see about objective. First, to design and develop a prototype version of a pit-stop power generator. Second, to analyze the function, performance and cost of the pit-stop generator. Last but not least in the chapter 1 is the scope. First, to create a power source that can produce 12 volt to light up a low voltage bulb using piezoelectric technology. Second, the pit-stop generator generates power using piezoelectric technology. Third, the electrical generator is by imposing weight onto the machine. Fourth, the battery is used to store the power generated from the generator.
Hi, my name is Umeysh KARUNAHARAN, matrix number AA200258, and today we are going to be looking at the literature review of our final year project. The introduction is, it is common to see each household in Malaysia own at least one car. Even during the COVID-19 pandemic, it was hard to see the roads empty. This encouraged us to initiate our pit-stop power generator project. Our study is mainly related to pressure and vibration. So the piezoelectric device constructed would be placed on the road right before the white lines of a junction to ensure the automobile's frontal tires land on the gadget to generate pressure. The massive pressure produced would contribute to the increase in voltage so that the volt produced may reach up to 12 volts. Piezoelectric sensors are made up of polarized ions within crystals. It can withstand up to 1000 psi pressure and measure up to 5 volts. The temperature does have an effect on the sensitivity, but it can be overcome if the materials are used properly. It is also easily manufactured with low-cost materials. Our previous studies taken from previous work, which is the footstep power generation using piezoelectric tile. This study suggests that electricity produced from this energy released by footsteps. Piezoelectric transducer in the device transforms mechanical energy into electrical energy. From this paper, we understood that piezoelectric sensors are capable of producing a renewable source of energy used to generate electricity. Next is the mobile charger using piezoelectric effect paper. It suggests that piezoelectric is a cleaner source of energy for future generation. A piezofilm can generate sufficient electrical density which can be stored in rechargeable batteries for later use, so to avoid any wastage. They also managed to create a major impact in piezoelectric study, where the future scope was to create a system that is able to charge any gadget. The next paper is the state-of-art piezoelectric vibration energy harvesters. This paper shows two novel piezoelectric vibration strength energy harvesters. One lumped mass single axis impact lead ball piezoelectric vibration power harvester, and the other one is a clamped free beam single axis impact lead ball piezoelectric vibration power harvesters. From this, we concluded that temperature does have an effect in the performance of piezoelectric sensors. So, moving on to our project gap. Our project uses pressure force to create low-cost renewable source of energy. The difference from the other studies mentioned previously is the method it uses, which is the weight of the cars to generate massive pressure and vibration. To get this, the device is positioned in a strategic place which is right before a junction to attain massive pressure. The concept we use is the higher the pressure strain applied to the device, the larger the power produced by the pit stop power generator. That's it from me. Now let's move on to our methodology. Thank you very much.
A very good day, my name is SRIKOOHEN, matrix number AA200317, and today I will be explaining about chapter 3 methodology. Okay, 3.1 system design. Now we will be looking at the block diagram. Okay, the block diagram for our project goes something like this. First, piezoelectric sensors. From those sensors, circuit. From circuit to the desired output, and from the desired output finally to the car ramp, also known as the prototype. 3.2 methodology. Now we'll be looking at the flowchart. Okay, the flowchart for our project goes from project suggestion to idea generation, planning, approval idea from supervisor, proposal, examination of proposal by supervisor, the circuit design, the physical design, detail design, to material listing, report writing, to circuit construction, to prototype construction, and finally testing. Now let's look at the flowchart step by step. The first one, project suggestion. How did we come up with this project? As we all know, piezoelectric is the new age technology of electricity. So more research has to be done in order to discover the wonders of piezoelectricity. So piezoelectric was confirmed as our project. The second one, idea generation. The main purpose of this project is to light up rural areas where it is usually dark at night. By this way, road accidents can be prevented. Sometimes thefts can be prevented. The third one, planning. The planning of FYP report was done. The first 4 chapters were targeted to be finished by the end of semester. The fourth one is approval idea from supervisor. The basic idea was presented to supervisor along planning to provide a clearer picture. So many suggestions were given by the supervisor, including where to place the prototype. The fifth one, proposal. Proposal was initiated to get permission from panels to conduct the project. The title of the project was set as pit stop generator. Okay. The sixth one is examination of proposal by supervisor. The draft of proposal was checked by supervisor and mistakes were pointed out. The errors were analyzed by team members and corrections were made. Circuit design. The current is generated by the piezoelectric sensor when force is applied. The current flows to diode bridge rectifier. Here the current is converted from alternating current AC to direct current DC. The current then reaches the capacitor and the charge is stored inside the capacitor. The current from capacitor flows to a resistor to control the current. From there, the current will flow to a LiPo battery and the remaining current will be stored there. When the switch is turned on, the current from LiPo battery will flow to the 12-volt light bulb. Jumper wires and connecting cables are used to flow the current. Physical design. To understand how the prototype works, it can be divided into three parts: part A, part B and part C. Okay, the dimensions for part A, part B and part C as follows. The dimensions is given by length times height times width. For part A, the dimensions are 30 cm by 30 cm by 2.54 cm. For part B, the dimensions are 30 cm times 30 cm times 2.54 cm as well. For part C, the ramp, the dimensions are 15 cm by 30 cm by 2.54 cm. Detailed design. The material used to construct this prototype is mild steel. Okay. As I said earlier, this assembly can be divided into three parts: part A, part B and part C. Part A is a metal board which will be placed above. This board is important due to the fact that it holds the bolts which will eventually be used to press down the piezoelectric plates. Part B is a metal board which will be placed underneath. This board is extremely crucial because piezo plates will be placed here. Okay, they will be stacked on top of this board facing upwards. Part C are basically two ramps at each end of the metal board like mentioned earlier. The function of this ramp is to help the car's tire to move smoothly on the board, and the elevation of the ramp help the cars to get on top of the ramp in no time. Detailed design. The material used to construct this prototype is mild steel. Okay. As I said earlier, this assembly can be divided into three parts: part A, part B and part C. Part A is a metal board which will be placed above. This board is important due to the fact that it holds the bolts which will eventually be used to press down the piezoelectric plates. Part B is a metal board which will be placed underneath. This board is extremely crucial because piezo plates will be placed here. Okay, they will be stacked on top of this board facing upwards. Part C are basically two ramps at each end of the metal board like mentioned earlier. The function of this ramp is to help the car's tire to move smoothly on the board, and the elevation of the ramp help the cars to get on top of the ramp in no time. Material listing. The raw materials for the prototype will be listed and purchased. Moving on to report writing. Okay, FYP report is crucial when it comes to project. The report is divided into 4 chapters which are introduction, literature review, methodology and finally testing. Okay, testing. When the LED was connected directly to the piezoelectric sensor just for test purpose, the LED light up. So this actually shows that the current is actually flowing. Now let's look at results and discussion. 4.1 expected outcomes. During the testing, the circuit consists only of one piezoelectric plate, a bridge rectifier, diode, capacitor, switch, resistor and LED. A single 49mm piezoelectric plate can produce around 1.2 to 1.5 voltage, which is enough to light up a small LED. During the construction of the circuit, the LED does not light up due to the incorrect fixing. So only the LED was tested by direct connection with the piezoelectric just to test its flow. When the LED is connected directly, it lights up indicating the current flow.